Hello, in this lecture we'll find out the radius of the circle. In the drawing we have a big semicircle. Inside this big semicircle we have two semicircles and a circle. We know that this line segment equals to 140 units and this line segment equals to 70 units. Our mission is to find out the radius of this circle. Okay, first of all, we will define the relevant points here. This point will be A, the center of this semicircle will be B, the center of the biggest semicircle will be defined as O. Here, the touching point of the two semicircles will be defined as point C. The center of the smallest semicircle will be defined as D. And the touching point between the smallest semicircle and the biggest semicircle, this point will be defined as E. The center of this circle will be defined as F. The touching point between the circle and the smallest semicircle will be defined as G. And the touching point between the semicircle and the circle will be defined as H. And finally, the touching point between this circle and the biggest semicircle, this point will be defined as I. Okay, so we will define the radius of the biggest semicircle as capital R. Capital R is the radius of the biggest semicircle, and we will define this small r as the radius of the circle. Small r is the radius of the circle. That is the radius that we are looking for. According to what is given as the question, line segment AF, this line segment AE, this line segment equals to AC plus CE. Okay, AE equals to AC plus CE. That is to say, AE equals to 140 units plus 70 units. AE equals to 140 units plus 70 units. 140 units plus 70 units, it is 210 units. AE equals to 210 units. But what is actually line segment AE? Although it is very easy to see that AE is the diameter of the biggest semicircle. And we know that the diameter of any circle or semicircle is twice as long as the radius. And we define the radius of the biggest semicircle as capital R. Therefore, AE, the diameter, must be equal to 2 times capital R. So 210 equals to 2 times capital R. We'll divide this equation by 2, and we'll get that capital R, the radius of the biggest circle, equals to 210 over 2, that is 105 units. Okay? The radius of the biggest semicircle, capital R, equals to 105 units. Here, line segment OE starts from the center of the biggest semicircle, that is to say from point O, and ends at point E. That is exactly the definition of a radius. That is to say, OE is the radius of the biggest semicircle, that is equal to 105 units. So I write it down. OE equals to 105 units. Likewise, line segment AO starts from point O, that is the center of the biggest semicircle, and that's at point E, that is the point of the biggest semicircle itself. And we have also line segment AO starts from point O, that is the center of the biggest semicircle, and that's at point A, that is the point of the biggest semicircle itself. That is to say, AO is the radius of the biggest semicircle, that is equal to 105 units. AO equals to 105 units. It is given us the question that AC, this line segment AC, equals to 140 units. But what is line segment AC? Line segment AC is the diameter of this semicircle. And because of the fact that the diameter of this semicircle equals to 140 units, it means that the radius must be equal to half of it. So AB, that is the radius of this semicircle, must be equal to 140 over 2, that is 70 units. Likewise, line segment BC starts from the center of this semicircle and ends at point C, that is the point of the semicircle itself. This is exactly the definition of a radius. That is to say, BC is the radius of this semicircle, that equals to 70 units. Likewise, it is given us the question that this line segment CE equals to 70 units, and CE is the diameter of the smallest semicircle. So the diameter of the smallest semicircle equals to 70 units, therefore the radius must be equal to half of it, that is to say 70 over 2, that is 35 units. So DE, that is the radius of this smallest semicircle, equals to 35 units. And CD, that is also the radius of the smallest semicircle, is equal to 35 units. Okay? What is the length of line segment BO? From a drawing, it is very easy to see that BO equals to OA minus BA. OA minus BA equals to BO. I'll write it down. The length of line segment BO, it is equals to OA minus AB. So BO equals to OA minus AB. OA, it is the radius of the biggest semicircle, that is equal to 105 units, minus AB. AB is the radius of this semicircle, that is equal to 70 units. So it is 70. So in conclusion, found out that BO equals to 105 units minus 70 units. 105 minus 70, it is 35. So we found out that BO equals to 35 units in its length. BO equals to 35 units in its length. And what is the length of line segment OX or XO? OC, it is actually this line segment is line segment OC. This is the arrow. OC. What is the length of line segment OC? The length of line segment OC is equals to OE minus CE. Again, OE minus CE equals to OC. I'll write it down. The length of this line segment OC is equal to OE minus CE. Repeat again. The length of line segment OC equals to OE minus CE. So OC equals to OE. OE is the radius of the biggest semicircle, that is equal to 105 units. Minus CE. CE equals to 70 units according to what is given us in the question. It's actually the diameter of the smallest semicircle. So CE equals to 70. So in conclusion, OC is equal to OE minus CE. It is equal to O equals to 100, OE equals to 105 units and CE equals to 70 units. So OC equals to 105 minus 70, that is 35 units. Found out that line segment OC equals to 35 units in its length, so we write it down in the original drawing. That OC equals to 35 units in its length. In the next step, so we will define, so R is the radius of this small circle, and in the next step I will present to you two new rules, and we will implement the two new rules in our drawing. We actually have rule number 10. According to rule number 10, if two circles are touching each other internally, then the straight line that connects their centers together passes through their touching point. So in this drawing we have those two circles. The small circle is inside the big circle, and therefore they are touching each other internally at point N. The center of the small circle is at point M, the center of the big circle is at point O, this point. And the straight line that connects their centers together is OM. According to rule number 10, the straight line OM must pass through point N, that is their touching point. That is to say, OMN is one straight line. OMN is one straight line. Okay? And what is the length of OM? That is actually the distance between their centers. The distance between their centers equals to capital R, that is the radius of the big circle, minus small r, that is the radius of the small circle. It is very easy to see that O n, that is equal to capital R minus MO minus NM, that is equal to small r, will give us exactly the distance MO. So capital R minus R equals to the distance between their centers, OM. Okay. Then we actually have also rule number 11. According to rule number 11, if two circles are touching each other externally, then the straight line that connects their centers together passes through their touching point. So in this drawing we have two circles that are touching each other externally at point N. Okay? So the center of the big circle is at point O, then the center of the small circle is at point M, and the straight line that connects their centers together is OM. And according to rule number 11, the straight line OM must pass through point N, that is their touching point. That is to say, O and M is one straight line. Okay? O and M is one straight line. Line segment O and M is one straight line. And what is the distance between their centers? The distance between their centers is OM. The length of line segment OM, and the length of line segment OM equals to ON, that is capital R, it is the radius of the big circle, plus NM, that is small r, that is the radius of the small circle. That is to say, the distance between their centers equals to capital R plus small r. Okay? So we can actually implement the two new rules in our drawing. So here we'll join the center of this semicircle that is point B with the center of this circle that is at point F. So those two circle and semicircle have an external knot between them at point H. That is to say, they are touching each other externally at point H. And therefore, the straight line that connects their centers together, that is to say, the straight line BF, must pass through their touching points, that is actually point H. The straight line BF must pass through point H, that is to say, BHF is one straight line. Okay, BHF is one straight line. Point F is the center of the circle, point H is a point on the circle itself, therefore HF is the radius of the circle that is equal to small r according to our definition. Likewise, point B is the center of this semicircle, point H is the point on the semicircle itself, therefore BH is the radius of this semicircle that is equal to 70 units. So in total, the distance between the centers of the semicircle and the circle BF equals to 70 plus r units. Okay. Likewise, we join the center of the smallest semicircle, that is to say, it is at point D, with the center of this circle that is at point F. Okay. So the circle, the smallest semicircle, have an external knot between them at point G. That is to say, they are touching each other externally at point G. And according to rule number 11, the straight line FD that connects their centers together, the set line FD must pass for their touching point, that is to say for point G. That is to say FGD is one straight line. Here point F is the center of the circle, point G is the point on the circle itself, therefore FG is the radius of this circle that is equal to small r, according to our definition. Here point D is the center of the smallest semicircle, point G is the point of the semicircle itself, and therefore GD is the radius of the semicircle that is equal to 35 units. Therefore, the distance between the center of the circle and the center of the smallest semicircle, FD, equals to R plus 35, or 35 plus R. Okay, so we can write down that FD equals to 35 plus R. FD equals to 35 plus R. And we have already found out that FB equals to 70 plus R. What is the length of side BE or line segment BD? The length of line segment BD is equals to BO plus OD. BO plus OD. So BO is equal to 35 degrees and OD equals to 35 plus 35 degrees, that is 70 degrees. So in total, BD equals to 35 plus 35 plus 35, that is 105 units. So BD equals to 105 units. We will join the center of the biggest semicircle, that is to say point O, with the center of the circle, that is to say point F, together by a straight line. So OF is the distance between the center of the biggest semicircle to the center of this circle. The biggest semicircle and this circle have an internal notch between them at point I. That is to say, they are touching each other internally at point I. Why? Because the small circle is inside the biggest semicircle and they are touching each other at point I. And according to rule number 10, the straight line that connects their centers together, that is to say OF, must pass for point I, that is their touching point. That is to say OFI is one straight line. OFI is one straight line. Point F is the center of the circle. Point I is the point on the circle itself. Therefore, Fi is the radius of the circle, that is equal to small r. Point O is the center of the biggest semicircle. Point I is the point of the biggest semicircle itself. Therefore, OI is the radius of the biggest semicircle, that is equal to 105 units. So OI equals to 105 units and Fi equals to small r. Fi equals to small r. And what is the distance between the center of the circle and the center of the biggest semicircle? The distance is Fo. And according to Rule number 10, whenever we have an integral length between two circles or semicircles, the distance between their centers, that is to say FO, will be equal to the radius of the big circle minus the radius of the small circle. That is to say, FO equals to OI minus FI. I write it down. FO equals to OI, that is the radius of the biggest semicircle, minus FI, that is the radius of the circle. So FO, the distance between the centers of the biggest semicircle and the circle, will be equal to OI, that is capital R, and capital R equals to 105 units, minus FI. FI is small r. So in conclusion, we found out that FO, the distance between the center of the biggest semicircle and the circle, FO equals to 105 minus R units. FO equals to 105 minus R units. Okay? So, in the next step, I will present to you a new rule, and we will implement the new rule in triangle BFD. This triangle BFD. We'll implement the new rule in the green triangle BFD. So, the new rule is Stewart's theorem. Stewart's theorem. Stewart's theorem is true in any triangle, so the triangle that I will draw could be any triangle. Here, this triangle, triangle ABC, could be any triangle. This is triangle ABC. And we know that the length of side AB is equals to A units, side AC equals to B units in its length, and finally side BC is equals to C units in its length. And we also have here line segment AO. This line segment AO equals to D units in its length. And we also know that line segment BO equals to M units in its length, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation will be true. That A squared times N plus B squared times M is equal to C D squared plus M times N. Okay? So, triangle ABC could be any triangle. So, in any triangle, this equation is true, that A squared times N plus B squared times M equals to C times D squared plus Mn. So we actually can implement the new theorem, the Stewart theorem, in our triangle. So I'll copy the green triangle BFD in a new page, and we'll implement Stewart's theorem on the green triangle, triangle BFD. So this is triangle FBD, the recovered from the original drawing. We have here line segment FO. Line segment FO equals to 105 minus R units. 105 minus R units. Side BF of this triangle, triangle BFD, equals to 70 plus R units. Side FD of triangle FBD equals to 35 plus R units. It is 35 plus R units. And here side BD of the green triangle BFD equals to 35 plus 35 plus 35. Okay, it is 35 plus 35 plus 35. 3 times 35 is 105 units. So BD equals to 105 units. Line segment BO equals to 35 units. And line segment OD equals to 35 plus 35, that is 70 units. So actually, this is a triangle FBD with all the values of its line segment. Here we will implement Stewart's theorem on this triangle, triangle FBD. According to Stewart's theorem, BF squared times OD, BF squared times OD plus FD squared times BO equals to BD. You open the brackets here, it is BD. Inside the brackets we will have FO squared, FO squared plus BO times OD. BO times OD. All inside the brackets. So BF squared, BF is 70 plus R, therefore BF squared is 70 plus R squared times OD. OD is 70, so we substitute OD by 70 plus FD squared. FD equals to 35 plus R, therefore FD squared equals to 35 plus R squared times BO. BO is 35, so we substitute BO by 35. And it is equal, on the other side of Stewart's equation, we have BD. BD is 105, so we substitute BD by 105. Now we have brackets. Inside the brackets we have FO square. FO is 105 minus R. Therefore, FO square is 105 minus R square plus BO is 35 times OD, that is 70. Okay, so actually this equation is the implementation of Stewart's theorem in our triangle FBD. So in the next step we will define 35 as x. 35, the number 35 is equals to x according to our definition. So we'll substitute in this equation 35, or the multiplication of 35 by x. Okay, so here we have 70 is 2 times 35, and 2 times 35 is 2x according to our definition. So it is 2x plus r squared times 70. 70 is 2 times 35, that is to say it is 2 times x. Plus, here we have 35, so we substitute 35 by x, so here it will be x plus r squared times 35. 35 is x, so we substitute 35 by x. It is equal, in the other side of the equation we have 105. 105 is 35 times 3, that is to say it is 3x. So we substitute 105 by 3x. And inside the brackets we have 105 is 3x minus r squared plus 35 is x, and 70 is 2 times 35, that is to say it is 2x. So it is, this expression in total equals to x times 2x. Okay, this is the equation of the substituted 35 by x. Here we will divide this equation by x. Here x will get cancelled, here x will get cancelled, and here also x will get cancelled. So what is left from this equation after we cancelled x? What is left is actually we have here 2 times 2x plus r squared plus x plus r squared. This is equal to, in the other side of the equation we have 3, inside the brackets we have 3x minus r squared plus x times 2x is 2x squared. So it is plus 2x squared, all inside the brackets. So here we'll open the bracket on this side of the equation. So we'll have here 2 times, inside the brackets we have 2x plus r squared. 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared, plus 2 times 2x times r. 2 times 2x times r is 4xr, so it is plus 4xr. And we have also this expression, x plus r squared equals to x squared plus r squared plus 2 times xr. Okay? So we finished in this side of the equation. We move to the other side of this equation. And we have here 3, and inside the brackets we have 3x minus r squared. 3x minus r squared equals to 3x squared, it is 9x squared. plus r squared minus 2 times 3x times r is minus 6r plus 2x squared, all inside the brackets. Okay, so here we'll open the brackets here and we'll get that 2 times 4x squared is 8x squared plus 2 times r squared is 2r squared plus 2 times 4xr is 8xr plus x squared plus r squared plus 2xr, and in the other side of the equation we have 3, and inside the brackets we have 9x squared plus 2x squared is 11x squared plus r squared minus 6r. Okay, so we have 8x squared plus x squared is 9x squared plus 2r squared plus r squared is 3r squared plus 8xr plus 2xr is 8xr plus 2xr is 10xr. And in the other side of the equation we will open the brackets. 3 times 11x squared is 33x squared plus 3 times r squared is 3r squared plus 3 times minus 6r equals to minus 18xr. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step we will subtract 9x squared from this equation, and we'll get that 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr, and it is equal to 33x squared minus 9x squared equals to 24x squared. Okay, and we have here what is left is it is minus 18xr. So zxr equals to 24x squared plus 18xr. Here we will add to this equation 18xr, and we'll get that 10xr plus 18xr is 28xr, and it is equal to 24x squared. Here we will divide this equation by x. It is allowable to divide by x because x is a positive number. It is not equal to 0. So here 28xr over x is 28r, and 24x squared over x is 24x. So we found out that 28r equals to 24x. Here we'll substitute x by 35, and we'll get that 28r equals to 24 times 35. Okay. 28 equals to 28R equals to 24 times 35. Here we will divide this equation by 7 and we'll get that 28 over 7 is 4, so this expression in total equals to 4R, and it is equal to 24 times 35. So 35 over 7 is 5. So this expression equals in total to 24 times 5. Here we will divide this equation by 4 and we get that 4R over R is R. 24 over 4 is 6. So in total, in this side of the equation, we have 6 times 5. So we found out that R equals to 6 times 5. 6 times 5 is 30. So R equals to 30 units. That is the answer to our question. Here, the radius of this circle R equals to 30 units. So in the next step, I will summarize the lecture. So, in the drawing, we have the big semicircle. Inside this big semicircle, we have 2 semicircles and 1 circle. And we know that line segment AC equals to line segment here. Line segment AC, this line segment AC equals to 140 units in its length, and also this line segment CE equals to 70 units in its length, and our mission is to find out the radius of this circle. Okay, so first of all we defined the radius of the biggest semicircle is capital R, and the radius of the small circle is R, small r. Then we gave names to the relevant points here. This is point A, this is the center of this semicircle is point B. The center of the biggest semicircle is at this point, point O. The touching point between the 2 semicircles here is at point C. The center of the smallest circle is at point D. And finally, the touching point between the smallest semicircle to the biggest semicircle is at this point, point E. Okay, then we defined the touching point of the circle, the smallest semicircle as G. We defined the touching point of the circle, this semicircle as H. We defined the center of this circle as point F, and finally we defined the touching point of this circle with the biggest semicircle as point I. Okay, and it is actually given us in the question that line segment AE, it is equal to 140 plus 70 units. AE, according to what is given us in the question, equals to 140 plus 70 units. That is actually 210 units. But what is actually AE? AE is the diameter of the biggest semicircle. And we know that according to our definition, the radius of the biggest semicircle is equal to capital R. Therefore, the diameter must be equal to twice of the radius, that is to say, the diameter AE must be equal to 2 times capital R. The diameter AE that is equal to 210 units must be equal to 2 times capital R. Here we divided this equation by 2 and we got that the radius of the biggest semicircle equals to 210 over 2, that is 105 units. So here the radius AO of the biggest semicircle equals to 105 units, and the radius OE of the biggest semicircle also equals to 105 units. Okay, likewise, we know that the diameter CE of the smallest semicircle equals to 70 units, therefore the radius must be equal to half of it, that is to say 35 units. So the radius DE equals to 35 units, and the radius CD of the smallest semicircle equals to 35 units. Likewise, it is given us the question that the diameter of this semicircle equals to 140 units. Therefore, the radius of this semicircle must be equal to half of it, that is to say 140 over 2 is 70 units. So the radius of this semicircle AB equals to 70 units, and here the radius BC of this semicircle also equals to 70 units. Okay, then we found out the length of line segment BO. From the drawing it is very easy to see that BO equals to OA minus BA. Again, OA minus BA equals to BO. Okay, I repeat again. BO equals to OA minus BA or AB, it is the same. So BO equals to OA. OA is the radius of the biggest semicircle that is equal to 105. So OA equals to 105 and BO equals to 70. So BO equals to 105 minus 70 units. 105 minus 70 is 35. So I found out that the length of this line segment BO equals to 35 units. Then we found out the length of this line segment OC. The length of this line segment OC, from the drawing it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. I'll repeat again. OC equals to OE minus CE. So OC equals to OE. OE equals to 105 units. This is the radius of the biggest semicircle. Minus CE. CE equals to 70 units. It is actually the diameter of the smallest semicircle. So in conclusion, I found out that OC equals to OE minus CE. It is 105 minus 70 units. 105 minus 70 is 35. So I found out that OC equals to 35 units. Here OC, this line segment, equals to 35 units. Okay. Then, in the next step, I presented to you two new rules, and we implemented the two new rules in our drawing. According to rule number 10, if two circles are touching each other internally, like in this drawing, the small circle is inside the big circle, and the small circle touches the big circle at point N. So we have here two circles that are touching each other internally at point N. Then the straight line that connects their centers together, that is to say, the center of the big circle is at point O, and the center of the small circle is at point M. And the straight line that connects their centers together is MO or OM. So the straight line OM must pass through their touching point. Their touching point is at point N. So the straight line OM must pass through point N. That is to say, OMN is one straight line. OMN is one straight line. Okay. And what is the distance between their centers? That is to say, what is the length of line segment MO? MO equals to capital R minus small r. Okay. The difference between their, on the I, is the distance between their centers, MO. Then we have also rule number 11. According to rule number 11, if two circles are touching each other externally, the two circles are not one inside the other, but they are touching each other externally at point N. Point N is the touching point, or the point of tendency between them. Then the straight line that connects their centers together, the center of the big circle is at point O, the center of the small circle is at point M, and the straight line that connects their centers together is OM. So this straight line OM must pass through their touching point. Their touching point is at point M. So that is to say O and M is one straight line. Okay, O and M is one straight line. And the distance between their centers is OM. It is very easy to see that OM equals to capital R plus small r. OM is capital R and M is small r. So capital R plus small r is the distance between their centers. So we can implement the two new rules in our drawing. Why? Because in our drawing we join the center of this semicircle, that is to say point B, with the center of this circle, that is to say point F, together by a straight line. Okay, so the straight line BF that connects, we have here external length between their centers, between the two circles, that is to say the circle and the semicircle are touching each other externally at point H, and therefore here the straight line BF that connects their centers together must pass through their touching point, that is to say from point H. That is to say BHF is one straight line. BHF is one straight line according to rule number 11. And what is the distance between their centers? The distance between their centers is FB, and FB equals to the radius of this circle plus the radius of this semicircle. The radius of this circle is small r, and the radius of this semicircle equals to 70 units. So the distance between their centers FB equals to r plus 70 units. Okay, here FB equals to 70 plus r units. Likewise, we connected the center of this circle, that is to say point F, with the center of the smallest semicircle, that is to say point D, together by a straight line. So here we have external length between the smallest semicircle with this circle. They are touching each other externally at point G. And according to rule number 11, the straight line that connects their centers together, that is to say FD, must pass through their touching point, that is to say from point G. That is to say FGD is one straight line. FGD is one straight line, and the radius FG is the radius of this circle, that is small r. The radius of the smallest circle is 35 units, and therefore the sum of the radii is r plus 35, that is the distance between their centers FD. Here we can write down that FD equals to 35 plus r units. Likewise, we found out, actually, we connected the center of the biggest semicircle that is located at point O, this point, with the center of this circle that is at point F. And this small circle and the biggest semicircle have an internal knot between them at point I. That is to say, they are touching each other internally at point I, this point. And whenever you have internal knot between two circles, then the center, the straight line that connects their centers together, OF is the straight line that connects their centers together, must pass for their touching point. Their touching point is this point I. So OF must pass for point I. That is to say, OFI is one straight line. OFI is one straight line. Fi is the radius of this circle that is equal to R. And what is the length of OF? OF equals to OI minus Fi. Again, OI minus Fi equals to OF. So OF equals to OI, that is the radius of the biggest semicircle, that is 105, minus Fi, that is R. That is to say, OF equals to 105 minus R units. OF or O equals to 105 minus R units. Then what is the length of line segment BD, or the length of side BD of the green triangle FBD? BD equals to BO plus OD. BO equals to 35 and OD equals to 35 plus 35. So therefore BD equals to 35 plus 70. That is 105 units. Repeat again. BD equals to 3 times 35, that is 105 units. Okay, so in the next step, I actually presented to you a new rule, and we implemented the new rule in our green triangle FBD. The new rule is Stewart's theorem. Stewart's theorem is true in any triangle. So if we have here a triangle ABC, that would be any triangle. And we know that the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. We also have here line segment AO that is equal to D units in its length. Line segment BO equals to M units in its length, and line segment OC equals to N units in its length. So according to Stewart's theorem, the following equation is true, that A squared times N plus B squared times M, A squared times N plus B squared times M equals to C. C is the length of side BC, and inside the brackets we have D squared plus M times N. So it is C, D squared plus Mn. Okay? Again, according to Stewart's theorem, A squared times N plus B squared times M equals to C. Inside the brackets we have D squared plus Mn. And this equation is true in any triangle. Why? Because triangle ABC could be any triangle. So we actually implemented the Stewart's theorem in our triangle FBD. So I copied triangle FBD in this new page, and we implemented Stewart's theorem in this triangle FBD. Okay, we found out all the sides of the triangle and all the line segments here. According to Stewart's theorem, we get that BF squared times OD, BF squared times OD, plus FD squared times OB. This is in one side of the equation. It must be equal to BD times FO squared plus BO times OD. FO squared plus BO times OD. Okay, so this equation is the implementation of Stewart's theorem in our triangle FBD. BF equals to 70 plus 1, therefore BF squared is 70 plus 1 square. OD is 70, FD is 35, and BD is 35 plus R, and it must be equal to BD is 105 units. Inside the brackets we have FO square. FO is 105 minus R. Therefore, FO square is 105 minus R square plus BO times OD. BO is 35 and OD is 70. Okay. So here we defined the number 35 as x, and we substituted 35 for the multiplication of 35 by x. And we found out that $70 is 2 times 35, therefore it is 2x plus r square times times 70, and 70 is 2 times 35, that is to say it is 2x plus 35 is x, so we have here x plus r square times 35 is x, so we substitute 35 by x, and it is equal to 105. 105 is 35 times 3, that is to say it is 3x. Inside the brackets we have again 105 is 3x minus r square plus 35 is x, and 70 is 2 times 35, that is 2x. Okay, then we divided this equation by x. Now x will get cancelled, x will get cancelled, and here also x will get cancelled. What is left from this equation after we cancelled x? Here we have 2 times 2x plus r square plus x plus r square equals to 3 times, inside the brackets we have 3x minus r square plus 2x square. Then we open the brackets here, so it is 2 times 2x plus r square equals to 2x squared, that is 4x square, plus r square plus 2 times 2x times r, it is 4xr. And here we have also x plus r square. X plus r square equals to x square plus r square plus 2 times xr, and it must be equal to 3. Inside the brackets we have 3x minus r square. 3x minus r square, it is according to the algebraic identity that a minus b square equals to a square plus b square minus 2 times ab. So 3x minus r square equals to 3x squared, that is 9x squared, plus r square minus 2 times 3x times r, that is minus 6xr, plus 2x squared. Okay, so here we open the bracket. Here 2 times 4x squared is 8x squared, 2 times r squared is 2r squared, and 2 times 4x squared is 8x squared, and we have also here x squared plus r squared plus 2xr, and it is equal to, here we have 3, inside the brackets we have 9x squared plus 2x squared is 11x squared, plus r squared minus 6xr. So we have here 8x squared plus x squared is 9x squared, 2r squared plus r squared is 3x squared, and we have 8xr plus 2xr is 8xr. So in this side of the equation we have 9x squared plus 3r squared plus 8xr. In the other side of the equation we open the brackets here, 3 times 11xr, 3 times 11x squared is 35x squared. 3 times r squared is 3r squared, 3 times minus 6xr is minus 18xr. Here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. Here we subtracted 9x squared from this equation. 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr. In the other side of the equation we have 33x squared minus 9x squared is 24x squared, and we also have here minus 18xr. So here we added 18xr to this equation. So 10xr plus 18xr is 28xr. So in this side of the equation we have 28xr. In the other side of the equation we have 24x squared. 1 equals 18x squared minus 18x squared, or minus 18x squared plus 18x squared is 0. So we found out that 28xr equals to 24x squared. Here we divided this equation by x. 28xr over x is 28r, and 24x squared over x is 24x. So in conclusion, we found out that 28r equals to 24x. Then we substitute x by 35, and we found out that (28r) equals to 24, and x is 35. So it is 24 times x, that is 35, equals to 28r. Here we divided this equation by 7, and we got that 28 over 7 is 4, so in this side of the equation we have in total 4r. In the other side of the equation we have 35 over 7 is 5, so in total in the other side of the equation we have 5 times 24. So we found out that 4r equals to 24 times 5. We divided this equation by 4, and we found out that 4r over 4 is r, and 24 over 4 is 6. So in total we found out that r equals to 6 times 5. 6 times 5 is 30, so we found out that the radius that we are looking for, the radius of this circle small r, equals to 30 units. Okay, thank you very much.